Quick revision video on the ideal gas equation. So we'll start with the essentials. It's used when conditions are not at room temperature and pressure, so there's no mention of RTP in the question. So the equation itself is PV equals nRT. So we'll go through all the terms. The P stands for pressure in pascals, or PA for short. The V stands for volume, and that's in meters cubed. I'm going to go through the conversions in a moment. N is the number of moles of gas. R is the gas constant, which has a value of 8.314 joules per mole per Kelvin, and that's on the data sheet, so you don't have to remember that value. And T is the temperature in Kelvin. So often what they'll do is give you one of these terms in the incorrect units, and you've got to convert them before you sort of type the numbers into your calculator. So we'll look at a couple of those, the sort of trickier ones. So the volume one is causes the most problems in my experience. So I've got this little diagram here. So often they'll give you the volume in either dm cubed or cm cubed. So you can see if you're going from dm cubed to meters cubed to use in the equation, you need to divide by 1000. If you've been given the volume in cm cubed, you actually have to divide by 1,000,000 to get it into meters cubed. The other one I'm going to look at is temperature. So to go from degrees C to Kelvin, you add 273. So we'll look at a couple of questions now. So here's the first one. In this one, we're going to calculate the volume of gas. So if you want to have a look at the information, pause the video and then play on when you're ready for the answer. So the first thing I've done is worked out the moles of propane. Just be careful, it's a kilo of propane, but we need to use grams to work out moles. So 1000 grams over the MR of propane is 44, gives us 22.73 moles. Ideal gas equation, and then rearrange for V, and then we'll put the numbers in. So the first one, N, got to be careful here because we want to know the moles of carbon dioxide that's going to be formed. So it's a 1:3 ratio, so that might catch some people out there. Multiply by the gas constant and the temperature, which was already in Kelvin, and then divide by 100,000, that's 100 kilopascals. That comes out at 4.5349 meters cubed. Remember, the volume is meters cubed for the ideal gas equation, and we want to get that into dm cubed, so we need to multiply by 1000. So it is 4530 dm cubed to 3 significant figures. So question 2 now, this one looks at how to calculate the MR of a gas. So again, if you want to pause the video, have a go, and then play on when you're ready. So ideal gas equation, and then rearrange for the moles. We want to calculate the moles of gas. We've got the mass, and we can work out the MR from that. So the numbers, the pressure, 101,000 pascals. So volume now, we'll get the diagram back up for the conversion. So we'll go on cm cubed to meters cubed. So we've got to divide by 1,000,000. All I do is stick a 10 to the minus 6 on the end there. So 2183 times 10 to the minus 6. It'll put that into meters cubed. 8.314 for the gas constant, and the temperature is 298 Kelvin, so 25 degrees C, add 273 on to get it into Kelvin. So put the numbers in, we're getting that many moles of gas. MR is mass over moles, so we get an MR of 71.0 to 3 significant figures.